Hi and welcome to our new episode and the second episode of this Java features and cool stuff series with Sander. So we did another episode earlier where we talked about gave a little bit of an overview of the features and all the cool things and what to do and what not to do. Well, mostly what to do when you're on Java 8 or earlier and then kind of trying to move forward. And I think we will do another round of a bit more deeper dive into modules and a bit more tools around that and stuff. And well, before we get started, just to mention that again, we have Sander with us today. He is from the Netherlands. He works as a consultant at Luminous, and he is one of the authors of the Java Modularity book. So it's you and Paul who wrote this great book. And thank you for coming. And well, on the other side, that's the usual suspects. That's me, Rustam, and
Mats.
Yeah. Okay, so enough with the introductions. I think we'll kind of jump back to the fun world of Java. So we talked about like overview, and we had a little bit of an overview of the things, but we kind of promised in the previous episode to have a deeper dive into the module system. And where should we start? What should we start?
So let's assume that you've migrated to Java 11, right? So you took all the hurdles that we talked about earlier, and now you're on this new and fancy version of Java, and you finally get to use modules. But then you're there, okay. I've never used a module system, maybe. So the question is, of course, why would I use this, right? And I think it's important to think about that first before diving into like the mechanics of the module system and all the technology behind it. And just to tell a story of how we at Luminous look at modularity. When you develop products, right? And then you need to take a long-term view on development because you might have a code base that you're building for years. That's right. Large teams, maybe different people. And we all know what happens. You all start out with a very nice diagram on the whiteboard, right? With all nice boxes and arrows, and you start coding, and the architect changes, and the team changes, and everything starts to get like a big tangled mess of code, right? And this even happens in services, in microservices. So I'm not just talking about big monoliths of the old days. So this is really where modularity as an architectural principle comes in. And what we at Luminous believe is that doing modular development really helps us to be more agile, to create more maintainable software as well. Also, like I said, with a long-term view. And there are actually three principles to modular development that help with that. And the first one has to do with the fact that if you're going to create a long-lived and large system, then you really want to have decomposed parts, right? So you want to decompose your domain into independent parts as much as possible, so you can have independent teams working on that. You can have a clear overview of the architecture of your system. But then you need to bring these parts back again into a working functional application. And so what we used to have in the Java world is we had jar files, right? So just put a bunch of jar files on the class path and hope for the best. That's sort of how it goes. That's very true. Because the class path really isn't that intelligent. So jar files don't know about each other. They don't know about any dependencies between them. So we had to invent tools around the Java ecosystem like Maven and Gradle to do this. So what happens if you're doing modular development with Java modules is that you can now encode this information about the dependencies between modules into the module itself. So the Java language, the compiler, the runtime, they all know about these dependencies and they can help you with maintaining these dependencies. So that's one thing.
That's the kind of thing we as developers typically have to keep in our mental model while developing.
Exactly. It's all about developer discipline, right?
That's
right. Which may be very well if you have a super awesome team of developers, which we all have, but we also know that in practice, when time is tight, then people take shortcuts and your architecture suffers. So that's one thing. That's one of the principles of modularity. The other one is about, okay, if I have these modules, then I want to be absolutely clear about what is the interface of this module. So what is something that other modules may use versus what is, and that's the third principle, what is encapsulated inside of a module. So you want to hide as much implementation details as possible, and you want to be as stable in your outside API to the outside world. And these principles, I mean, we all know these as developers, and we even try to apply this, maybe using dependency inversion, Spring, dependency injection, things like that. The Java module system takes this to the next level and also helps you to encode this at a language and a platform level. So what you now have is the ability to group packages into a module and to add a module descriptor where you can say, okay, this module depends on these and these other modules. And by the way, of this collection of packages, only some of the API packages are exported to the outside world. So that means that any other module that takes a dependency on this module will never be able to reach into your implementation details. And this really helps you to create maintainable systems and to create flexible systems. You can easily replace a module because as long as it implements like the same interface, who cares how to implement it, right?
Exactly. Yes.
So these are all principles that play in the background. And the cool thing is that this allows you to translate these whiteboard designs not just into spoken rules within your team, but also into enforced rules inside of the module system of Java.
So exactly. So this is like there are actually two aspects to this. One of them is kind of security. Well, in a way, security, so you don't get to run things that you're not supposed to run in a way. But then the other thing is also that I guess we'll talk about a bit more about that later. But it's more about like you don't really put things you don't need into your kind of compiled code, so you kind of get to throw out some stuff. And
a very cool thing is that the JDK itself also has been modularized. So
exactly,
there are now many parts in JDK, and your application doesn't necessarily need everything, right? If you're writing a web application, you don't need Swing, maybe you don't need JavaFX. Because of all this explicit information in these module descriptors, we can now sort of create a minimal graph of modules that are necessary.
And it's really nice because like one thing is the security, and as well, it's a very nice thing to have and everything. But then you have the other bit more kind of practical thing is that you will have a smaller footprint. Well, technically, I mean, you potentially can have a smaller footprint, right?
Right. Yeah. So it's not just about like the enforcement that we talked about of module boundaries and dependencies, but it also enables a new feature, and that's actually a tool called Jlink that you can use with the newer version of Java that uses this information to create a so-called custom runtime image, which only contains your application modules and the dependencies, of course, and then just the modules from JDK that your application needs, and it just generates a very small custom runtime image rather than having this big JDK with everything that you don't need. And you can use that as basis for your Docker image or for your IT device deployment or what have you.
And there was it's kind of amazing to see how the footprint goes from several hundreds of megs to
just 20, 30,
nothing, right?
Yeah, true.
Can you use that when you're going from, say you just evolved from Java 8 to Java 11, can you then use Jlink or something to see what parts of the JDK you?
Yeah, so there's a technical answer to that, which is yes, you can do that, but it's not easy. It gets easy when you start doing modular development, right? Because then all the information is there about what parts of the platform that you're using. You can also sort of bootstrap your own custom runtime image using Jlink, even if your application isn't using modules yet. But then you have to figure out yourself which of the modules you need to bundle into this custom runtime image. So that is possible, and it's also actually a scenario that we described in the Java 9 Modularity book. But it gets easier if your whole application has been modularized. That's right. But I mean, let's face it. We're not there yet, right? I mean, if you look at the adoption of newer versions of Java.
I was about to ask
that. People are currently, like in all the polls, you see that about 80% of the people are still on Java 8 currently. And then the few people who have moved to Java 11 or later, well, they just start looking around. Okay, what are these modules and how can I use them? And so there's definitely ways to go here in terms of people learning about this feature and starting to use it.
Do you have any feeling of how, because like one thing is the adoption rate of like 8 and 9 and 10 and 11 and stuff, but how do you know about the adoption rate of how many of those who migrated to 9 plus have actually done anything with modules. And
Yeah.
stuff.
So yeah, that's a bit hard to measure. The only data point,
definitely.
the only data point that I know is that the JCP last year did a survey, and there they found that of the people who moved from Java 8 to Java 9 and later, about 20 to 25% have started working with modules, which is on the high side, I would even say, for such a new and invasive feature. The other thing that you can talk about is, of course, what about libraries, right? Because typically we don't build applications completely from scratch. We use things like Hibernate, Spring, and stuff like that. And there you definitely see that we're moving there, but we're moving there slowly. So actually together with a lot of several other people at Adopt OpenJDK, which is a community initiative around OpenJDK. We wrote sort of a module scanner tool, which scans Maven Central just to see how many artifacts currently do have this module descriptor that we talked about. And there are like 4K modules now in Maven Central, which taken on the complete Maven Central, of course, is just a drop in the bucket. But I must say, lots of these libraries that have added support for newer versions of Java and even for modules, I mean, they are already active in the popular libraries. So that's good, right? So, and there's also lots of unmaintained stuff in Maven. So the percentages, I mean, they're also not that indicative, but there's definitely a long way to go.
Yeah, because if you pick everything in Maven Central, you'll get lots of legacy stuff that is pretty much dead code, I suppose.
Yeah.
And then it will be interesting to actually have a look at how between like amongst all the most used packages, most downloaded packages, they kind of top something.
That would be a very nice analysis, definitely.
It would be interesting to actually have a look at that.
Yeah.
Like, okay, say that just since most people are still on Java 8 and like new to modules and such, where would you start?
Yeah. So it might be tempting to just take your current Java 8 application and start porting it to Java 11. And first you would definitely stay on the class path for this migration. And then start thinking about applying modules to this application. But you're actually having two problems at once then. One is learning about the module system and about the technology behind it and how to use it. The other one is actually modularizing your application, because let's face it, the lots of applications that we develop, me included, aren't really modular when you really look at them. And there are some very, very interesting dependencies, let's say, if you look at these code bases. So you're tackling two problems at once. So if you're migrating to Java 11 and later, I would definitely recommend taking existing applications from the current class path to the Java 11 class path. But if you're starting to look at modules, I would definitely start with just create a new project and just create something yourself to get a feel for how the features of the module system work, what keywords are there, how a module descriptor looks like, and just all these things before even thinking about applying this to older code bases. And it might very well be that for some of these older code bases, it doesn't pay off to actually modularize and use a module system, because well, it's just there, and okay, it may not be pretty, but it works and it's still good enough. But especially if you're looking at new developments, creating new services on Java 11 and later, I would really advise on reading up on the module system and seeing if you can apply this from the start. So you can have the benefits that we talked about.
A question that some people might have that don't have that much experience with these modules and stuff would be probably something like, well, you've heard word modules before, but like maybe in a context of Maven and stuff like that.
Yeah.
What is the kind of, is there any connection, or is there anything that might be a good idea just to say a few words about that? I think
there's definitely a connection between how build tools approach structuring your code base and how the Java module system does that. So in fact, Maven in its core also supports Java modules already since Java 9. And what you typically see there is that a single Maven module maps to a single Java module. So you would add a module descriptor to the source root of your Maven module, and Maven actually understands out of the box how to work with this and how to compile this as a modular Java application. If you're looking at Gradle, for example, as a build tool, it doesn't currently support the Java module system in its core. But there's a very good plugin created by Paul Walker, my co-author from the Java 9 Modularity book, which does this. And so for both the big build tools, there's a pretty good story about using them together with the module system.
That's really cool.
Yeah.
Because like the one thing that I kind of want to mention, since you mentioned Maven and stuff, is that when you use modules there, that's actually might be one of the reasons to start using or look at using that, is that when it sees modules, it will try to build them in parallel and use several. I mean, the core is available there, so you might get improvements in build time as well, which is instead of just having one module, everything kind of old monolithic kind of thing.
That's certainly advantages of having a modular Maven build. Yeah.
Exactly. Yeah. So it's also a very, very important thing to mention, because like I've seen on some systems where we had like, I don't know, 450, 500,000 lines of Java code, the time would go down by what, 20-25%, just because of modules. And that was before module system of Java and everything. It was just modules and Maven 3 and stuff like that.
Base.
Yes, exactly. Yeah. So I think that might be also another good thing. So when people are just sitting here and thinking like, what's in it for me?
Yeah.
It's like, well, okay, you get cleaner code, you get much nicer things, it's easy to update, easy to maintain, and all the other things. But it will actually compile faster as well, possibly. I mean, your mileage may vary, and all that
depends on the
stuff,
situation,
but
of course. Yeah.
Sure. But that's cool. Okay. Are there any kind of pitfalls and things kind of you shouldn't do or be a bit more aware of doing or not doing? Oh, sorry.
Yeah. So one that we already talked about is, okay, don't just grab this feature and try to slap it on any code base that you encounter, because that will not work. Modularity isn't about using a certain module system or technology. It's about being able to decompose your domain, your application in a sane way. And well, that's just software architecture, right? Software design. So don't expect a module system to fix this for you. It will still be hard work to actually modularize an application.
And you have to identify your boundary context.
Yeah, definitely in terms of like domain-driven design. Yeah,
yes,
and that's the hard part, right?
Exactly.
Another one is the nice thing about the module system, if you start using it, is that you don't have to wait for all your libraries to also be modularized, because there is a feature called automatic modules, which turns existing jar library files into modules, which is all well and good, but there are some pitfalls associated with that, in the sense that these automatic modules, they work, but they're not great modules, in the sense that they export everything and they sort of take a dependency on everything, because, well, the information isn't there. So in the future version of the library, when there is a module descriptor, there might be parts now encapsulated that you're using and stuff like that.
Yes.
So even though automatic modules are a great feature to get started to modularize your own application, so you don't have to wait on all your dependencies to modularize, there are some caveats that you need to take into account when using automatic modules. So that's one that I definitely want to mention as well.
Just a question that kind of popped up in my head that I kind of think that might be a good idea to kind of make a bit more clear. What do you think? I mean, say I have an application, right? So, and then I upgraded the Java version, so I'm running on Java 11 or something, but I haven't done anything with the modules. Can I just run it on Java 11 without kind of running it in compatibility mode and kind of going back to Java 8 or, well, pre-module Java kind of compiled version? Or can I do that? That might be something that people might wonder. Those who are not really familiar with the whole.
Yeah, and so you're saying you want to make a step, but you want to still stay compatible with the
I mean, I wouldn't like the first step. I would guess. I mean, first natural step would be to upgrade the JDK, like Java version, to say 11. But, well, I don't want to do anything with modules just yet. I just want to make it run there. Can I do that?
Yeah, definitely. So modules are completely optional. The class path is still there.
Yeah.
There are some issues that we talked about, of course, in the first episode of this podcast. So you do have to take care of those.
Exactly.
But yeah, nothing stops you there, and just to take this first step without using modules yet.
Yeah, it's just kind of trying to ask over again, so we can underline some of the features.
Clear. I mean,
yes. And I think it's a very good idea to kind of be aware of that and know what to do and how we can do it a bit more gradual in a nice way.
Yeah.
Anything else? What kind of if we want to kind of conclude with some kind of call for action again, I mean, what would be like the kind of short conclusion?
Yeah. Well, I mean, you already sort of mentioned it, but the most important step that you can take is to actually get on Java 11. And even if you're just running on ClassPath there, that's fine. I mean, just try to get there, because there's many reasons why you shouldn't stay in Java 8.
Yes.
And if you're actually there, I think you owe it to yourself to at least explore the new capabilities of the modular system in JDK, because, like I said, there are really tangible benefits to doing modular development. And even if you, in the end, decide not to use the Java modular system itself, I truly do believe that the principles that are behind that should be exhibited in your code base.
I definitely agree with that. Where do you assign for that?
All right.
Oh, that's amazing. Thank you very much again for coming and for agreeing to talk with us.
Yeah.
It's been really nice. It's been a pleasure to have you here. And well, thank you all for watching, for listening, and we'll see you soon. Bye-bye.
Thank you. Bye.